last subnet claims. Philip, thank you so much.
Thanks, everyone. Hi. I'm Philip, and I'm here to present you claims, the Bittensor subnet that will enable an AI to do precise scientific reasoning. So we all know that AI already ate the internet. The problem is that I can't digest science yet. To put some numbers on it, more than $3 trillion are spent every year around the globe for research and development. Researchers have published more than 300 million academic articles. That's arguably the most important source of human knowledge that we have. Yet, all of it has been written for optimal human consumption. Literally none of it is available in a structured data format that machines can actually make sense of. And when you're using frontier models for scientific purposes, you're seeing that. So if you ask ChatGPT or Claude a scientific question, you're getting back a confidently sounding answer, and very often it hallucinates references. And that is a very well-known problem. It isn't solved by the fact that these models have already been trained on the scientific literature, but there is a well-known solution for it, which is retrieval augmented generation, or RAG. So we actually built one of these RAG systems. It's called SciReef. It's an AI research assistant that is available as a web app, as a mobile app, as an MCP server. And you can ask it any science-related question. It will give you an accurate answer that is backed up by the most recent, most relevant publications. You have the references. And we actually compared SciReef against frontier models using Scholar QA Bench. That's a benchmark that was published in Nature earlier this year. And it's pretty clear that these RAG architectures, they solve the hallucinated reference problem. Now, these RAG systems are obviously an amazing step into the right direction, but they still have substantial shortcomings. And one of them is that they can only parrot what the author said. They do not really understand how strong is the underlying evidence, where are the gaps in the literature, where are the missing links, and so on and so forth. And that is exactly why we need to build claims. So we need to translate the scientific literature into a claim evidence graph that actually makes this negative space of science computable. And this is what will enable AI to identify the most promising research opportunities, help us prioritize hypotheses. And I think this has enormous potential for speeding up scientific progress. Now, our team is actually exceptionally well positioned to build exactly this. So I'm a professor in economics. I've published more than 70 articles in peer-reviewed journals, including Nature and Science. I've led a large-scale consortium of scientists from around the globe doing large-scale genomics association studies on behavioral outcomes. And by doing that, we fixed the replication crisis in behavioral genetics, and we built the data standard that this field is now running on. I previously founded DSci Labs together with Sina Iman, our CTO. At DSci Labs, we built SciReef, the AI research assistant that I just talked about. We also built the first decentralized publishing infrastructure for science. And Sina, our CTO, he's a very experienced full-stack developer. He specializes in machine learning, blockchain, and cryptography. He was one of the earliest employees at Palantir. He has also worked for Booz Allen, was involved in many startups over the years. And we have Christian Rossler, who is actually also with us in the room here today. And Christian is also a professor in economics, and he specializes in game theory and mechanism design. And this is why I brought him on board. So he actually spent the last couple of months developing a general theoretical framework, a theoretical model, that can be used to construct optimal incentive mechanisms for any Bittensor subnet. So if we come to the ecosystem, this would be an expertise that we would bring to the network and that we would be more than happy to share with everybody. So we also have already a enterprise client that wants to pay us for a client. So meet Simon. Simon works at a well-funded biotech startup, and he's currently wondering through which mechanisms does 5-MeO-DMT affect mental health outcomes. And for him, this means that he has to identify, he has to read, he has to synthesize literally thousands of different papers. And for his company, there's a lot at stake, right? So depending on what molecule, what particular mechanism they're going to dedicate their budget on, this is actually going to move a multi-million-dollar budget, and if they get this wrong, this could actually, this could flip the company. So the stakes couldn't be higher. And Simon, of course, he has enormous time pressure, and he needs AI to help him to actually synthesize all this literature. So this is why they wanted our help. And they're actually not the only ones. There's others that we talked to that have exactly the same problem. So in order for AI to help with this problem, we need to identify the relevant papers, and then we need to go into these papers and literally extract every claim that they made, put it into a schema, subject, predicate, object, link it to ontologies for sense-making purposes, link it. Every claim needs to be linked to the underlying evidence. And then we can also add a score that tells us how confident we are in the evidence that was provided. And we think that Bittensor is the right place to build this type of signal. So there's at least 3 reasons why we believe this needs to be on Bittensor. The first one is, if you have several miners working on this, it means we have extracted diversity, which means we have calibrated confidence per claim. Second, doing this in a decentralized network is ultimately much more capital efficient than running this inside a single company. And third, and this is most important, on Bittensor, we have a language to design an incentive system that rewards the miners and the validators to continuously improve the quality of the data. And in this particular case, data quality is going to be the only thing that matters. Whoever has figured this out and who has the most accurate data will dominate the market, will win the competition. So how is this going to work in practice? Well, the validators, they're channeling the demand for a particular topic or a field by defining a list of papers that the miners can work on. Then you have several miners competing and extracting the claims and the evidence from these papers, adding their judgment, and sending back these structured data formats to the validator. The validator evaluates what the miners have submitted. They compare it to a reference model, and importantly, they compare it to a gold set. So gold sets are basically human-curated data sets where the authors of the original paper or experts in the field have actually extracted the claims and the evidence themselves. So we have an exogenous source of truth that we can inject into the system. And then the validators aggregate the data into the canonical database. So we're thinking about the incentive design here in a very principled way. Christian's theory basically tells us that, first of all, we need to identify if there are more than one behavior that we want to incentivize among the miners. And then for every behavior we want to incentivize, we need to have an independent information channel that allows us to approximate that behavior. Then we can score it, and then we can construct a reward function around it that can meet optimality criteria. So in our case, there's 3 types of behaviors that we want to incentivize: complete coverage, accurate extraction, and then evidence evaluation. So for all of these 3 channels, we have different information that we can use to actually measure the miner's performance. 1 and 2, there is an objective ground truth that we can compare it against. And then we can have gates where the miners first need to do complete coverage before they can earn rewards for accurate extraction. And ultimately, before they can earn rewards for evidence evaluation, they actually need to do 1 and 2. So there's dependency gates. The final product is then going to be this canonical claim evidence database that is going to be available as a metered API, MCP server connection. And importantly, we as a company, we can then do projects together with enterprise clients and define and implement custom-made ontologies and controlled vocabularies that help making sense of the literature in exactly the way that the client needs it. And this is ultimately the Palantir Foundry model for science. So every time we do that, it enhances the value of the data, and it creates a lock-in effect, and it makes the data better. And of course, the data will ultimately also have some use for AI fine-tuning purposes. So we think that the market for this is somewhere between $20 to $60 billion. And just to wrap this up, what I propose is to build an important missing part of the data infrastructure for AI on Bittensor, We think that Bittensor is the right place to do this. We would love to join the network, and we would love all of you to support us to build the future of science.